is equal with the secant x. So to find the function y is equal with the secant x, to find the inverse function, first of all, let me draw the function. We already know the secant x is a reciprocal function of the cosine. And the cosine x, we already know, has a period of 2 pi. If I'm going here, I want to find the critical points. I'm taking this in a half. Here, half of this is 3 pi over 2. So I'm dividing this period in four of the same places, and here is a pi over 2. And already we know the amplitude of the cosine is 1. Okay, so, or in other words, the range is from -1 to 1. And here are going to be the critical point. Those are the critical points here, and here is a 2 pi and 1. If we are drawing the function, let me draw with the green. So that's how it's going to be. And this is going to repeat this period. It's going to repeat from -infinity to +infinity. But now if we are drawing the secant x has vertical asymptotes. So the vertical asymptotes are going to go through this critical point whenever the graph of the cosine x intercepts the x-axis. And those are the points. And here is the same thing. And those are the points. And now cosecant is going to be everything. The cosecant is going to be everything that is in it starts at the point whenever are the extreme values in a maximum and a minimum values of the cosine x. And here is going to be the secant. Secant is going to be here, are in the crest of this periodic function, and a thorough. And it's going to look something similar. But now, if we are applying the horizontal test, is not going to pass. The horizontal test here, if we are trying to pass, is going just in one restricted domain. And the restricted domain for this case is from 0 to pi. So in this interval. So in this interval, we are going to restrict this domain. And if we are applying, for example, from 0 to pi, whenever we are doing this horizontal test, is going to pass in this side, and also is going to pass here in this side here. But as I said before, if we wanted to solve analytically, to find the inverse function of a secant, we write y is equal with the secant of x, and now we are exchanging the variables. So this is the analytical interpretation, secant of y, and we take in the inverse of a secant, both sides, and we get the inverse of secant of x is equal with the inverse of a secant and the secant of y. This is 1, so y is equal with the inverse of a secant x. But this doesn't show a lot. But if we are taking here and we're drawing the y if we are interpreting geometrically, if we are constructing y is equal with the x here, and then we find that the function and inverse function are symmetric with respect to y. So we can do by hand, but if we are doing by hand, it's get just messy. But if we are doing with this calculator or electronic devices or Desmos or whatever is more convenient, I usually do in the Desmos, and it gives a beautiful picture here. And now if I'm looking here from 0 to pi, I'm looking this function here, and now I'm taking this interval 0 and 1. This part is symmetrical with inverse function, the one that start from 1 and 0. From this part here is, as we see here, this is symmetrical. Those two with respect to y is equal to the x, this part of the graph, from 0 to pi over 2. And if we are looking from pi over 2, we take this function to pi, and we take this part, what we said before, is symmetrical with the inverse function for this part here, from pi over 2, from pi over 2 from -1 to infinity, with this one, with this part of the inverse function. So this is symmetrical with this green part of the inverse function is symmetrical with this part of the red function here in this side. So those are as we see, symmetrical. And the inverse function, we already know whatever is the domain here in this function, here is going to be the range. So the domain is of the function y is equal to the secant x from 0 to pi, while the domain in the inverse function is from 0 to pi. Here is the range, the codomain. But if we are looking, for example, for the range of the function, y is equal to secant x is from minus infinity to -1 and from 1 to infinity. But if you look here, for example, for the domain is from minus infinity to -1 and is from 1 to infinity. So this is the fact. But if we want to look at just the inverse function alone, more clear, so this is the inverse function of secant x that is represented here in this picture. As we said before, the domain is from minus infinity to -1 and from 1 to infinity, and the range is from 0 to pi.